Welcome to the walkthrough for Assignment 4, Part B. The objectives of this assignment are to learn how to synchronize concurrent being gazes via a reader's writer lock, implemented using the Java StampedLock, and a fair semaphore, implemented using your solution to Assignment 3B. Videos describing Java StampedLock appear here and here. I recommend you watch these videos to ensure you understand Java StampedLocks. Naturally, this topic is covered in class as well. The fair semaphore and a Java StampedLock are used to enhance the Java Fork Join Framework implementation of the Planetary Simulator App from Assignment 4A. Assignment 4B focuses on the Palantiri manager, which is used to restrict the number of beings from Middle-earth who can concurrently gaze into a fixed number of Palantiri. The Planetary Simulator App is packaged as a project using the latest version of Android Studio. This app is written in both Kotlin and Java and demonstrates many Android capabilities. For the purposes of Assignment 4B, however, you only need to be aware of the following 3 directories. Simulator Manager's Palantiri StampedLock Fair Semaphore, which contains skeletons you need to fill in, as described below. App Source Test, which is a series of unit tests that exercise many Palantiri Simulator features and can be used to help test the functionality you implement for this assignment. And App Source Android Test, which is an Android Studio instrumentation test that runs your app automatically. You'll also need to integrate your enhanced solution for the Fork Join Pool folder from Assignment 4A into the latest greatest Fork Join Pool skeleton and use it as the implementation of the Being Manager for Assignment 4B. Please address all my comments from Assignment 4A into your Assignment 4B solution. To compile this code, you need to use the provided Android Studio project. You can run this project by clicking the green Run App button in Android Studio IDE, which should automatically select an Android emulator to run, assuming you have one created. The app's minimum API is 29, so you'll need to select an emulator that uses an API greater than or equal to 29, although I recommend you use API 30. If you don't already have an emulator created, you can create it by clicking on the AVD Manager button in the Android Studio IDE. You'll need to modify several files containing this Java skeleton code by completing the to-do you fill in here tasks to provide a working solution. Don't change the overall structure of the skeleton, just fill in the to-do tasks. And please don't delete the to-do tags. In particular, you'll need to finish implementing the following to-do tasks for this assignment in the StampedLock Fair Semaphore folder. StampedLock Fair Semaphore Manager.java, where you'll need to complete the to-do tasks in the various methods to implement a Palantiri manager via your Fair Semaphore implementation, a StampedLock, and a HashMap. Fair Semaphore Mo.java or Fair Semaphore Co.java. You need to complete the to-do task in various methods to implement the counting semaphore, implemented your solution to Assignment 3B with either a built-in Java monitor object if you're an undergraduate, or a Java condition object and reentrant lock if you're a graduate student. And finally, you need to complete the to-do tasks in the student.kt file to set the type field to either graduate or undergraduate, depending on which version of the assignment that you're implementing. As always, your app will be considered correct if it passes all the unit instrumentation tests and all the beings successfully complete their n iterations. A correct simulation should restrict the number of gazing beings to the number of Palantiri. In other words, if there are 4 Palantiri in the simulation, then only 4 beings should ever be gazing on the screen at any one time. When the simulation is running, the app view will display visual feedback to show Palantiri and being states, as well as the progress of their gazing iterations. If your assignment implementation is correct and doesn't throw any exceptions, then the app title bar labels will appear green when the simulation completes. If your solution is not implemented correctly or throws an exception, then red title bar labels will be displayed when the simulation completes. Graduate students, or students who are taking the course for graduate credit, must perform the following additional tasks. Enhance the StampedLock Semaphore Manager.java file to use Java functional programming features, such as method references, lambda expressions, and/or Java sequential streams in several places. Undergraduates are welcome to implement these Java functional programming enhancements, but it's not required. Skeleton code for this assignment is available in my GitHub account. Now that you've set up your GitLab account, simply pull this skeleton code into your repository, read it carefully, and complete the to-do markers. The additional work required by grad students is clearly marked. This part of the assignment is designed to deepen your understanding of synchronizing multi-threaded programs using Java stamped locks, which are more powerful, more complex, and sometimes more efficient readers-writer synchronizers compared with the spin locks and reentrant locks we covered in previous assignments. Now that we've walked through the specification for assignment 4B. Let's go ahead and take a look at the skeleton implementation. Turns out there's really only one file you have to be concerned with, though naturally you need to make sure that you've got a correct implementation of your fair semaphore implementation from assignment 3B. So please make sure you update all my comments, though you can leave those files where they were. So let's go ahead and take a look at StampedLock fair semaphore manager.java. This file defines a mechanism that mediates concurrent access to a fixed number of available Palantiri. It uses your fair semaphore for assignment 3B, just a plain old HashMap, and now the new piece of the puzzle is a StampedLock in order to mediate concurrent access to the Palantiri. This class implements a variant of the pooling pattern, which you can learn more about at the link here. So let's go ahead and take a look at some of the fields. One field is, of course, the fair semaphore, M available Palantiri, which is your implementation from assignment 3B. You've also got a Palantiri map, which is just a plain old hash map, very similar to earlier assignments. And then you have a new field you have to fill in here, which is pretty obvious, which is a StampedLock synchronizer that's used to protect the Palantiri state. Let's take a look at the build model constructor method. So what you'll do, as you've done before, is you'll make a new hash map, iterate through the list of Palantiri, and initialize each key in the map with true to indicate it's available. And then you'll go ahead and initialize the fair semaphore to use the fair implementation. And again, we'll see that the implementations you have to do depend on whether you're doing the grad student version or the undergrad version. Down here, you can use get Palantiri to get the list of Palantiri and then initialize each key in the Palantiri map with true. Grad students should use a Java stream to initialize the Palantiri map, whereas undergrad students can use it and implement it without using a Java stream, though you're certainly welcome to use a stream if you'd like. Down here, you'll initialize the semaphore to use the fair implementation. And once again, we split up the two implementations between undergrad and graduate versions, so make sure you do the right one. And then the final thing you'll do in build model is initialize the StampedLock, which is pretty straightforward. Let's come down here now and take a look at acquire. So the purpose of acquire is to get a Palantir, and it will block until one is available. This method should never return a null Palantir. However, it can throw the interrupted exception if a shutdown is being processed while a thread is waiting for a Palantir. And this is a little different from previous assignments, and I've actually gone back and updated previous skeletons. So now all the acquire methods in all the different Planetary Manager implementations all throw interrupted exception. So you'll need to go back and refactor your assignment 3B code to make sure that the acquire method no longer throws cancellation exception, which was kind of a strange vestige left over from a previous time, and make sure it throws interrupted exception. That will actually clean the code up a bit, make it a little shorter. So let's talk about what you need to do for acquire. So you'll acquire the fair semaphore, either the monitor object one if you're an undergrad or the condition object one if you're a grad student, using the interruptibly method. And then you'll use an iterator to iterate through the hash map in a thread-safe manner to find the first key in the hash map whose value is true, which of course indicates it's available for use. You'll then go ahead and replace this key with the value false to indicate that the Palantir isn't available and return that Palantir to the client. Now, a couple things to note here. There are actually some really clever ways of doing this using Java streams, which you have to be somewhat careful because it's a little bit more subtle than what you've done in the past. And the reason for that is described in this next paragraph. The implementation should demonstrate StampedLock support for upgrading a read lock to a write lock. So, of course, after you acquire the fair semaphore, then you have to go ahead and acquire the StampedLock as a read lock. And then you'll use your iterator. And the reason you're using an iterator here, instead of something like a for loop or a for each loop or so on, is so that you can restart your search at the beginning of the hash map if you're unable to atomically upgrade the read lock to a write lock. So what you need to do here, because this code is a little tricky, please take a careful look at the StampedLock upgrade example that's described in the Java documentation for StampedLock. And then, of course, also you feel free to go back and take a look at the videos that I did where I walk through how you would implement this in the context of the examples that we looked at that time. So when you're all done, if all goes according to plan, you'll then go ahead and release the stamped lock, which could either be a read lock or a write lock, depending on different circumstances, depending on how things went. And so you'll need to make sure you use the right unlock method. And of course, as always, make sure you use the try finally blocks to ensure that the lock is always released. And if something really strange happens and you don't get a Palantir, the end of the world's at hand. So in that case, the illegal state exception should be thrown, but this should never really occur in practice. So this method is a little tricky, but the good news is if you look at the StampedLock upgrade example and think carefully about what you're doing, you'll get a lot of good hints from that particular example. Let's now come down and take a look at release. Release will release the Palantir so it's available for other beings to use. What you're doing is you're giving it back a Palantir, and naturally you have to do some sanity checking to make sure you're getting the right Palantir. This particular code can also throw interrupted exception, and it can also throw the illegal argument exception. So the way this is going to work is as follows. You're going to update the status of the designated Palantir inside the StampedLock fair semaphore manager, in other words, inside the HashMap that's part of that. So it's now available for other beings to use after it's been released. This method, of course, should be efficient and it should be robust. For example, it should handle invalid Palantir values, such as null values, or values that are not valid keys in the hash map. Hopefully the tests will catch these problems, but make sure that you go back and look carefully at some of your earlier implementations, for example, your assignment 3B implementation, to see how you should do this. And if you are confused, come to office hours and/or please take a look at the frequently made mistakes video for assignment 3B. You should also lock and unlock the stamped lock field correctly to ensure mutually exclusive access to shared mutable state in a manner that's interruptible. So that's giving you a lot of hints about what you should do. Once again, the unit tests will hopefully yell at you if you try to do something besides what's described here. And then, of course, as we've been doing for the last number of implementations of the B assignments, only release the semaphore if the Palantir parameter is indeed correct. So those are really the key methods. Release, which is actually fairly straightforward. It just uses stamped lock. Acquire, which is a little tricky because we're using stamped lock with this kind of conditional upgrade model that we're trying to get you to understand from reading the example and looking at the code I walk through. And then the initialization is very much par for the course. You've seen this many times before. So that's the walkthrough for the skeleton. As you can see, there's really not a whole lot to it, but make sure that you come to office hours. Make sure you ask questions on Piazza if you run into any problems whatsoever. So now that we've walked through the specification and the skeletons for assignment 4B, it's time to finally turn our attention to the unit tests. So we'll go ahead and run those tests. And as you'll see, there's quite a number of tests this time. We have 180 tests in all, covering both grad and undergraduate versions. And this, of course, will test all your previous implementations from assignment 1 to assignment 4. You might wonder why we keep doing this, and there's a number of reasons for this. Naturally, one reason is we keep coming up with new and better ways to find bugs, so we update the test to reflect that. It's also just good to get in the habit of running regression tests, and this class is trying to give you some sense of what it's like to work for a commercial environment where running regression tests is very important, and perhaps even more important than that is passing the regression tests. Another thing to note here is we've made a few changes to the specification APIs for some of the earlier assignments, so you'll have to update your test implementations ever so slightly, or rather your update your class implementations ever so slightly in order to be able to pass the new tests. Just keep an eye out if you start failing tests in ways that look mysterious. That's probably what's going on, because I changed the signatures for the acquire method so that it doesn't throw the cancellation exception, but will throw interrupted exception, which is a much better exception for it to throw. And those are all done consistently now across all the different assignments. So as always, if you have any problems, don't hesitate to come to office hours. Don't hesitate to post questions on Piazza, and make sure that you don't go to submit your final solution in particular without making sure that all the tests run. People keep losing points because they're not integrating their code properly with either the newer tests, or they just never went and fixed their code with respect to the comments I gave for previous tests. So you're losing if you're doing that, you're losing a bunch of points unnecessarily, and that's, of course, not what we want to have happen. So again, let me know if you have any questions, and this concludes the final walkthrough for the final assignment for this semester's course on concurrent object-oriented programming.